Hi, everybody. I hope you're doing great. So this is how we're going to spend our next 9 weeks of pre-calculus. It's kind of crazy, but we're going to do the best we can. So today we are going to talk about the second part of 4.6. So before break, we had done the first part of 4.6, which was solving rational equations. So today we're going to talk about solving rational inequalities. I have little list of things that you're going to need. So you should have your chapter 4 notes, page 14. If you don't have those, get some paper, something to write with. I'm going to use some highlighters, and then a calculator or just a phone to do calculations and check some answers. So that's what you need to have. You need to hit pause. Go ahead and hit pause to get those things. Okay, so we're going to start with example 2. So this is on page 14. So we're going to start we're going to solve this inequality. Remember, before break, we were solving equations. So we want to figure out what values will make this left side of our equation less than 0. I didn't record. Shoot. Yes, I am recording because it's Screencastify. Oh my gosh, you guys. I recorded a whole lesson before, remember, without hitting record. That's why I'm freaking out. Okay, I've got it now. All right, so we want to figure out what values are going to make the left side less than 0. So what we're going to do for all these is we're going to start by solving the equation as though we didn't have that inequality there. That'll tell us what makes the left side equal 0. And then we can figure out, okay, well, what values would make it less than 0. So we're going to start out by solving this equation. So I'm just going to write it as x minus 2 times x minus 1, and then over x minus 3 times x minus 4 equals 0. I'm also going to set up a number line here, and we kind of did this before at the beginning of the semester when we were talking about domain and range and what possible values could make a function true. It's going to kind of be that same idea. That's why I have this little setup with like the interval and the point I'm going to test and then checking in whether or not it works. You don't necessarily have to make a table, and we'll talk more about that in a minute. Okay, so I want to solve this equation. So if I put that over 1 and just cross multiply, what's going to end up happening is, okay, if I do this times this, that's just 0, and then this times 1. So I'd be left with x minus 2 times x minus 1 equals 0. And so then if I solve this, I get x equals 2 and x equals 1. So those are the two values that make this left side equal 0. So I'm going to put those two solutions on my number line. The other thing that I have to think about is, because this is rational, I can never have anything that would make the denominator 0 as part of my solution. So I'm also going to have to put the 3 and the 4 on my number line. So let's start with that. I'm going to put the 3 and the 4 on my number line, and those come from, they give me 0 in the denominator. I don't have you guys here to tell me if I'm not on the screen. I've got to make sure I'm paying attention. Okay, so those come from what would make my denominator 0. So I have to exclude those from my solution. All right, and then I solved the equation, and I'm going to put those values on the number line. Okay, so first of all, whatever makes the bottom 0, this is always going to be an open circle. Okay, so whatever makes the denominator 0, always going to be an open circle. Now, whether or not these are open or closed is going to depend on the inequality, right? Because these values would make it equal 0. Actually, I want whatever makes it less than 0. So if I have a less than or a greater than symbol, I'm going to have open circles on the solution of the equation. And if it's a less than or equal to or greater than or equal to, I'm going to have closed circles on those solution values. Okay, so this is a less than. That means I'm going to have open circles. Okay, the reason I'm putting those on the number line is because those are the values that are the cutoff between this left side being less than 0 or being greater than 0. And so now what I'm going to have to do is, I have my number line split into 1, 2, 3, 4, 5 intervals. I'm going to have to check values on each of these intervals to see if they make this inequality true or false. That's kind of what we had to do when we were doing domain back in the couple sections we did from chapter 1. So I've got 5 intervals to check, from negative infinity to 1, from 1 to 2, from 2 to 3, from 3 to 4, and then from 4 to infinity. So 1, 2, 3, 4, 5 different intervals that we have to check. How many intervals you have is just going to depend on the inequality, right? Sometimes it might just be 3. Okay, this one happened to have 4. All right, so then what I'm going to do is I'm going to pick a number that falls in each interval. I'm going to plug it into my original inequality, and I'm going to see if that makes that true or false. Okay, so I could pick anything less than 1 and then substitute it in here and then see what I get. Okay, so maybe I choose to plug in this interval, maybe I choose to plug in 0, and here maybe I plug in 1.5, and then maybe 2.5, 3.5, anything bigger than 4. So like I could plug in 5, and I'm going to plug in here and then see, does that give me something less than 0? So that's here where we have the space where we could check. Now, some of you might find it helpful to make the table and fill that all in. And some of you might be able to just simply, kind of have your number line and put your number in and then just figure it out from there. Whatever works for you. You wouldn't necessarily have to do a table. So like if I were to plug 0 in here, I would have 0 minus 2 times 0 minus 1 over 0 minus 3 times 0 minus 4. And I would want to know, is this less than 0? Okay, so this is I don't know. When I think about this, it's like what, negative 2 times negative 1. This is negative 3 times negative 4. This is 2 negatives and 2 negatives. It's going to be positive. That there's no way that's less than 0. So this is not a solution. And then maybe I'm putting in the 1.5. So I could do 1.5 minus 2. Oh, my pencils are dying. Come on. All right. And then 1.5 minus 1 all over 1.5 minus 3 times 1.5 minus 4. And check, is that less than 0? It's a negative and a positive. So that's a negative. So that's going to be a negative answer. And again, you could get the value. Sometimes when you're comparing to 0, it's just easy to figure out, is your answer positive or negative? Because, if it's positive, it's bigger than 0. If it's negative, it's less than 0. But that one would work out. So that means that from here to here is part of my solution. Okay, and then I could plug 2.5. And so we're going to keep going. If you want to pause the video, you could pause the video and then try it out and see what you end up with. I'm sure I'm putting a 0 in there. Okay, so it's a positive and a positive and a negative and a negative. So that's positive. So that's a no. And then here I could plug the 3.5 in. There's no way to, always know for sure if you're going to get a solution or not, just based off, you just kind of have to try it out and see. Okay, so if I figure that one out, I want to know again, is that less than 0? And it is, so that is a yes. And then if I plug the 4 in and see, and again, you don't have to write it all out. You could just be using your calculator and comparing it to 0 and seeing what you get. Whoops, I want to put 5 in, not 4. Darn it. I went to put the 4 in. I was like, oops, I'm going to get 0 in the denominator. That doesn't work. So I have to put something bigger in. And is that less than 0? No. Okay, so then our solutions are from 1 to 2 and then from 3 to 4. So the way we're going to write our answer is using interval notation, because that's how we've written these. All right, so from 1 to 2 and then from 3 to 4. Remember, we put the union symbol there that showed that was part from both sets. Okay, so now why don't you guys hit pause, go ahead and try the next example and see what you end up with. Now, I have put in your assignment for today, so here it is. This is what you're going to be doing for today. But I did put the steps here, right? So first, create a number line to visualize the excluded values. Put any number that would give you 0 in the denominator is an open circle. They're excluded, right? Solve the equation. So everything that we just talked about, right? That, open circles, if it's less than or greater than, closed circles, if it's less than or equal to or greater than or equal to, and then test values. Okay, so I put that all in the instructions here for your homework. It's not even homework, everything's homework now. For your practice that you're going to be doing for me. And then if you get stuck while you're working on this, I've asked you take a picture of your work so far. I'll help try to figure it out for you. I only gave you 4 of them because they can get lengthy. And if anybody can figure out how to make this bigger in Google Doc, let me know so I can fix that so they're not always so small. Okay, so again, if you didn't pause it, try it. All right, so let's see what you should have come up with. I'm going to draw my number line. That helps me visualize what's going on. Okay, so I'm going to start by what gives me 0 in the denominator. So what gives me 0 in the denominator would be 1 and -1. So those are going on my number line. So -1 and 1 are going on my number line. And they're open circles, right? Anything that makes 0 in the denominator, open circle. All right, then I'm going to solve this as though it were an equation. Some of these with the zeros are kind of easier to figure out than others, right? You just want to know what makes this equal 0. But sometimes just to be consistent, the idea of we can always set up an equation, solve it. I can cross multiply here and I'd have x plus 2 times x minus 3 equals 0. So my solutions would be -2 and 3. Okay, so then these guys are going on my number line. I'm always worried I'm going to screw something up. I don't have you guys in here with me to tell me I'm screwing up. So if you find any mistakes, just shoot me an email and I will look it over and maybe put a note in the video or in Google Classroom. Hey, make sure at minute whatever I screwed it up. So because I don't have you guys here to make sure I'm doing it right. Okay, so there are my, again, 1, 2, 3, 4, 5 intervals. And if you just want to pick numbers and check, I could pick -3, -1.5, 0, 2, 4, whatever. You can pick any numbers you want. Again, you do not have to make the table. If it helps you to see all the possibilities and make sure you're checking, this should be a -2. I was looking at the number. Oh, I just realized something I screwed up. Maybe some of you did too. What did I say about when I have a greater than or equal to or less than or equal to? These make it exactly equal 0. So those can be included in my answer, and those should be, change my color here, closed circles. Glad I figured that out before I posted it. Okay, so these could equal it. These are going to be closed circles. And now that's going to change these to be brackets on the 3s. Now, when you test your values, some people are going to ask, well, couldn't I just test 3 if I wanted to? Because it would make it equal 0. But I really want to know what makes it bigger than or equal to 0. So I want to pick something in between. It's true that if you plugged the boundary numbers in here, it would give you an answer. But I know what it would give me. I know it would give me 0 because I just solved it and it gave me 0. So you want to pick something in between. All right, so again, I'm going to just plug my testing numbers in here. So I would have, -3 plus 2 times -3 minus 3 over -3 minus 1 times -3 plus 1, and then that's squared, and see what I end up with. Okay, so this ends up being, and I want to know, in this case, is it greater than or equal to 0? Okay, so just thinking about this would be a negative times, this would be a negative over a negative times, anything squared is always a positive. So that's going to be overall negative. I want something bigger than or equal to 0, so this is not a solution. Okay, here, if I plug in -1.5, so I have -1.5 plus 2 times -1.5 minus 3 over -1.5 minus 1 times -1.5 plus 1. And I want to know if that's bigger than or equal to 0. Now this bit I'm doing over here on the side with the negative times a positive and all that, that really only works if you're comparing to a zero. So here I'm thinking this would be positive times a negative. This would be a negative times anything squared is positive. So then that's a negative over a negative, which is positive. That means it's bigger than or equal to zero. So this is part of my solution. So this is part of my solution. All right, and then if I put the zero in, I want to know if that's bigger than or equal to zero. So that would be a positive times a negative over a negative times, that's always positive, negative times a positive. So that's a negative over a negative, which is positive, right? Yes. Okay. So that's a yes. Did I do that right? Yes, yes, negative, positive. Okay. And then here, if I pick 2, so if I do 2 plus 2 over 2 minus 3, all over 2 minus 0 over 2 plus 1 squared, is that bigger than or equal to 0? That's going to be a positive times a negative over a positive times a positive. That's negative. That doesn't work because I need it to be bigger than or equal to 0. And then if I put that 4 in, I can hear my kids in the background. I don't know what they're doing. Doing something crazy, I think. Okay, positive, that's positive, positive, positive. Okay, that's bigger than or equal to 0, so yes. All right, so my solution here is going to be, what I had 3, right? Okay, so the one we had 2 intervals, one we had this one we have 3 intervals. It just is going to depend on the situation, right? It's going to depend on what inequalities we had. It's going to depend on if it's the greater than or the less than, lots of things that are going into that. Okay, so there's my solution. Remember, it's always a parenthesis on your infinities. Okay, so 2 more examples I've got for you. Now these ones are a little bit different, so take a look at examples 4 and 5 and think about why those are different. You notice they don't have zeros on the other side. That means they're going to be a little bit more complicated to solve. But we're going to start out the same way. Okay, so I usually start by thinking, well, what would make my denominator 0? Because those values have to be excluded. Okay, and what would make this equal 0 would be 0. And what would make this equal 0 is 0, right? 6 times 0 or 3 times 0 is 0. So 0 is going to have to go on my number line. Open circle always. All right, so then we're going to have to solve this equation. Now, when we go to solve this equation, we're going to have to use what we talked about before a break, where we multiply through by the lowest common denominator. So when I do that, I think first about the 3, the 6, and the 4. What number do 3, 6, and 4 all go into? And they all go into 12. You could use 24 also. They all go into 24. But 12 would be the lowest common denominator. So that would cancel the 3. I also need to cancel an a. So this would be a 12a. And then here I think about, I want this to cancel. Okay, the 12 would cancel with the 6 and then the a. And then here I need the 4 to cancel, which it would. So all of these need to be multiplied by 12a. So I'm going to multiply all of these by 12a. So here, when I do this first thing, times 12a, the a's cancel, right? 12a times 12a over 3a, so 12a. If I think about multiplying that by the 3a, the a's cancel, and then 12 divided by 3 is 4. So, and then there's still this 2 here. So I'd have 2 times 4 plus, I still have this 5 here. Now I have to do 12a, and then it's over 6a. So the a's cancel, and 12 divided by 6 is 2, equals, now here when I multiply, 12 divided by 4 is 3. So I've got this 3 here times 12a divided by 4 is 3a. All right, so this is 8 plus 10 equals 9a. So I have 18 equals 9a. So a is 2. And that wasn't too bad, right? That wasn't too bad of a solve. So the solution is 2. And then I'm going to look. I'm going to be careful here. I'm going to make sure I look and see that's a greater than. That means I'm going to have an open circle on 2. Well, this one's not so bad either because look at only 2 things on my number line. So that's kind of nice. So I only have 3 intervals to check. So negative infinity to 0. I'm going to leave a little bit more space this time. 0 to 2, and then to infinity. And so again, I'm going to pick a number in each of those intervals. So maybe here I pick -1, here I could pick 1, here I could pick 3, and I'm going to plug them in. Now here it's a little bit more involved when you do the checking because it's not just comparing it to 0 like the last ones were. That wasn't too bad. Now it is, I need to know, is the left side, in this case, bigger than the right side? So I'm going to plug in, and I want to know, is this greater than 3/4 or 0.75? So you might look at that and say, I don't know, -2/3 plus -5/6, I don't know. Just put it in your calculator. All right, let's see. I did remember my Inspire. I had to go back to work to get a few things, and I did remember the Inspire. And is it going to have a horrible glare, or are we going to be able to see? We'll find out, I guess. Okay, so I have 2, we can see it, yay, over -3, and then plus 5, oops, I'll do the control divide, 5 over -6. And I want to know what that is. I'm going to hit Control Enter so that I get a decimal. So this is -1.5 greater than 0.75? It is not. So this is not part of my solution. Okay, remember, if you don't have the Inspire, you could just use Desmos, right? You could just use the calculator feature in Desmos, and it would do it for you. Okay, so now I'm going to plug, what did I say? 1 in. So I have 2 over 3 times 1 plus 5 over 6 times 1. Again, I want to know, is that bigger than 3/4? Now, we can do this in Desmos, and I can show it to you on the next one if you want. But remember, if you arrow up to highlight your last thing and hit Enter, then that brings that down. So if you wanted to just arrow in and change, like this is now going to be, instead of -6, it's going to be 6. So you could just kind of delete. That's more helpful in some of the ones later, like other problems where it might be like a lengthier expression. Okay, so I get 1.5 is bigger than 3/4. That's true. So yes, it's part of my solution. All right, and then finally, the last number I was going to check was 3. So 2 over 3 times 3 plus 5 over 6 times 3, and is that bigger than 3/4? All right, and if I want, I can arrow up, hit Enter, and I could just, again, go in if I wanted to. And this is an 18 now. I don't know, it just saves, I don't know, I feel like it saves a little bit of typing maybe. And then this is, what, 9? And I get 0.5. Is 0.5 bigger than 0.75 or 3/4? No. Okay, so this one, the solution is only this one interval. This was the only one that worked. So it's only from 0 to 2. It's the only thing that would make that inequality on the left, that left side of the inequality, bigger than 3/4. All right, so same idea with example 5. You're first going to, start your number line, think about what would make your denominator 0. Then you're going to solve that equation, test your intervals, and so on. So I really encourage you right now to hit the pause button and try this. Okay, try it on your own. And then maybe you do the first couple of steps. So see what makes the bottom 0. And then if you want to play and see what makes the bottom 0 to make sure you're on the right track, go ahead. And then maybe solve the equation. And then press play, make sure you did that right. I get not wanting to do the whole thing and making a mistake and then having the whole thing wrong. But, do try to do it on your own as much as possible. You'll get a lot more out of it than just watching me. So go ahead and hit pause. Okay, so now let's see. After you paused, let's check, see first, what would make the denominator 0? So what would make this 0 would be -1/2. Or if I set that equal to 0. And what would make this equal 0 would be -1. Oh, lovely fractions. I know that's exciting, right? Okay, so I have to have a -1 on here, and I have to have a -1/2 on here. And those will both be open circles. Okay, so now I'm going to solve this equation. Make sure I leave enough room. So I want to multiply through by a common denominator. I need all of these to cancel. So Use my little sticky note, make it happen. Do this. Okay. I need a 2b plus 1 to cancel out, so I need a 2b plus 1. I need a b plus 1 to cancel out. Okay, I need a b plus 1. Sometimes people on this one think because there's a 2b plus 1 and it's got a plus 1 that I can just say, oh, that works to cancel that, but it doesn't because of the 2. And I need this 15 to cancel, so I need all 3 of them. Fun, right? Okay, so this is going to get multiplied to everything. So when I multiply this times the 1 over 2b plus 1, the 2b plus 1's cancel. So I have this one here, which you don't really need to write, times b plus 1 times 15. I'm going to put my 15 in the front, just 1 instead of 1 times 15. I'll just have the 15 here. Okay, that's the first part. Plus, okay, I've got that 1, and then the b plus 1s are going to cancel, and I'm going to be left with the 2b plus 1 and the 15. So I'm going to write the 15 first again, and then I'll have a 2b plus 1 equals. We got that 8. Okay, the 15s cancel, right? And then I'm left with 2b plus 1 times b plus 1. Man, that goes into my space here. Okay, so now I need to solve this equation. So maybe at this point, hit pause again and try to solve the equation. So let's see, 15b plus 15 plus this would be 30b plus 15 equals 8 times. I'm going to multiply this out before I distribute the 8 in. Or you could distribute the 8 into this first one and then multiply those. The 8 does not go into everything. Okay, so if I multiply these together, it would be 2b squared, that'd be 1b, that'd be plus 3b plus 1. Over here, this is 45b plus 30 equals, this would be 16b squared plus 24b plus 8. And then I'm going to move these over. Oops, 30. And then I'm going to write my answer over here. So I'd have 16b squared minus 21b minus 22 equals 0. All right, that does factor, believe it or not. Put it in your calculator if you don't believe it. I'm just copying my answer. Okay, so b minus 2 times 16b plus 11. And then when I set those equal to 0, I get b equals 2 and b equals negative 11 over 16. Oh, more fractions. Okay, so b equals 2, not so bad, down here somewhere-ish. Okay, this is a greater than, right? So these are open, right? So it's a greater than, so these are open. All right, negative 11 over 16. Oh, what is that as a fraction, as a decimal rather? Because I don't want to deal with, I want to make sure I put on the right spot in the number line. So this is negative 0.6875. So it's hanging out somewhere in here, negative 11 sixteenths. Okay, open circle. Okay, so now you want to pick numbers that fall into each of those intervals and plug them in like we did on the last ones, and I used up all my space over here. So plug those all in and then see which ones work. So this would be, like I could pick here maybe negative 2. This was what, negative 0.685. So maybe here I pick like negative 0.9. Here I need somewhere between, this is negative 0.6875 and this is negative 0.5, like maybe negative 0.6 I could pick. Here I could pick anything between negative half and 0. I could pick, or in negative 1/2 and 2, I could pick like 0. Here I could pick 3. Okay, so go ahead, if you want to pause, pick a number in each of those intervals, and then check. Okay, so your final solution should be the interval from negative 1 to a negative 11 sixteenths, along with negative 1/2 to 2. Those would be the two intervals that should work for you. Okay, so again, when you are working on this, remember I put those steps at the top of the assignment. and do your best. And if you get stuck, please send me questions. And then please, if you need to, come to one of my Google Meet office hours and ask questions. I miss you guys. I hope you're doing well. Bye.